So this problem following from the practice set, and first a couple of parts. Part A and B are pretty straightforward. The part D is a bit tricky. So let's look at part A. And the velocity vector is consists of the component of x prime and y prime. And so when we derive the x prime, y prime with respect to t, and this will be what we expect to see after simplification. And moving on to the second part, B. This is also very straightforward, and if z is the speed, z is absolute of the velocity vector, and that means we have the square root of x prime square plus y prime square. And after you have performed the manipulations and simplification, you should arrive at this one. You can see, and z squared is just, square both sides will give you that, and 6.25 of cos square and 2.25 of sine square. Oops, I missed the square. Okay. And next, take the answer from B, derive this with respect to time t. You should able to get something which, well, you will get this exactly actually, minus 8 in sine t over 4 cos t over 4 after the differentiations, and also perform some steps to simplify the expressions. Well, in other words, the value of k in this instance is minus 8. Now the D is pretty tricky, so I'm gonna open up a new slide. But before I do that, I'd just like to briefly explain the validity of deriving z squared to do part D, because here we are actually looking for exact time when moving at the fastest speed and so on. In other words, we're talking about maximum and minimum of the motion of this particle. And here the original function, when we form it, is x equals to this, and when we squared it and derived it, the solutions obtained by setting it to 0, the derivative to 0, to find stationary points and so on, would be valid, because think about this: if you have a function, in this case with a z, let's just say the function looks like this, right? And these functions, there's a maximum point, and the maximum point is somewhere right here. I will mark it with a little x. So when you square the function, what happens now is that the function is gonna look a bit like this, okay? A bit higher perhaps, because you square each value at all the x values, but the maximum point would still correspond to the correct t value, to the same t value rather, and that's why you try using this z square to find the maximum or minimum point is a valid strategy. So now let's move on to the part where we're going to talk about part D. So let us first look at the question one more time. And in the first minute, that also means that 1 minute 60 seconds, and since t is a unit of seconds, so t is now bounded between 0 and 60. And I want to do something with this right hand side of the expressions. We know that now 2 sine a cos a is sine 2a. In other words, this is actually sine t over 2. And because we want to find the maximum minimum point, or rather fastest or lowest speed in this case, we set the dz squared dt equal to 0, and the solution to this would give us the fastest or lowest speed, whichever we want to find. So here now I need to be very careful, because really I am actually solving sine t over 2 equals 0. I can ignore the minus 4 because it's not relevant in this context, and because the argument now is t over 2, so the new I need to look at this argument in this way. So instead of using 0 to 60, I use t over 2 between 0 and 30, and 30 is approximately 9.5 pi. The reason I do this is that I'm going to put or write the answer, state the solution in terms of pi, and when you look at this, the solution will be 0 pi. So I could choose anything I want. I mean that satisfy the sine t over 2 equals 0 in an interval of period of pi, 4 pi, and so on until 9 pi. And I do not write 10 pi because of this situations here, the upper limit of the domain. So in other words, the solutions are really t equals 0, 2 pi, 4 pi, as you can imagine, and until the last one, 18 pi. So now recall that the dz squared dt is in fact minus 4 sine t over 2. I'm repeating it right here, minus 4, and we need to check which of these solutions are the maximum or the fastest speed. To do that, we use a sine diagram. So we need a sine diagram of d dt z squared. So it's going to be long. And let's do this. And we have a 0, and we put 2 pi, and put 4 pi, and 6 pi. And there's quite a number of that. 10 pi. So by checking the sign of the dz squared dt, remember, using sign diagram, so it's going to be positive. This going to be negative between 0 and 2 pi, and then between 4 pi and 2 pi and 4 pi going to be positive, and as you go on, it's negative, and between 6 and 8, positive, and this going negative, positive, and negative, and finally the 18 pi. So that allows us to see what's really going on, and that means this is going to be look like this, this. Okay, you get the idea. And that means from the sign diagram we're able to see the exact time where the maximum occurs, or maximum speed or fastest speed. Okay, the fastest speed will be when t equals to 0, and 4 pi, 8 pi, and 12, and finally 16 pi.